But regressions, people are like, oh, I can't make a window. I'm like, regressions are easy. Your data's sitting in front of your face. Make it lower or higher, right? I know when you're given just an equation that is harder. I get it, 100%. But yesterday I showed you to get the maximum and the minimum so that you can do your y min and max, right? Do the maximum and minimum using d plus amplitude, d minus amplitude. And then the period, just by doing 2 pi over b, then you can double that and that gets you your x's, right? So there is a nice way to get a really good window. It's to get the maximum in and the period whenever you're given a sinusoidal equation, okay? We did do regressions, we did that. Now we're going to go over ones, what if you're not given an equation? So we want to be able to be covered by anything that they give us. You can't say to me, Mrs. Lepp, I never learned that, okay? So we're not going to have that. So here we have, a Ferris wheel completes 1 revolution every 18 seconds. Now what I want you to think about is something that makes 1 revolution means if they start at the bottom of it, they start at a minimum and then they go back to a minimum, correct? So what does that 18 seconds actually represent? The period. Yeah. So 1 revolution every 18 seconds, that's actually the period. You're correct. Then at the top, a seat 16 meters above the ground, what is that giving us? The maximum. At the top, 16 meters above the ground, this is my maximum. And we do start with 0. Sometimes Ferris wheels do start on the ground. You step in, you go up, right? Sometimes Ferris wheels start above, most of the time. Sometimes Ferris wheels start below ground level. For example, if you've ever been on the Mickey one in Disneyland, you actually walk down to get into that, right? You are below ground level when you get on those ones. All right. At the bottom, it is 1 meter above the ground. What is that? The minimum. And they don't always give you all the same information, but when we with the information, you should be able to draw the Ferris wheel, sketch it. Now remember, this is something I need you guys to listen to because I explain things and then I get people like 10 minutes later being like, sorry, and then they ask the exact same question. So I swear, like, you go to an alternate universe. So stay here in this universe, okay? With sinusoidal regression functions, if they ask you to do one on a diploma, they have to give you 5 coordinates. 5. Like that table has to have a minimum of 5. It can have more, but it has to have a minimum of 5 because sinusoidal does this, right? So if you just had this and this, it could form a quadratic, right? So we need way more. So they need at least 5 coordinates, okay? So for you to calculate a regression from these word problems, we need at least 5, okay? So what I always do, a pendulum, for example, starts at a max, goes to a min, back to a max. That actually covers a sinusoidal regression as well, right? Max, min, max, max, min, max, max, min, max. And it has to be the same periodic function. If it does that, it can cover a sinusoidal curve. Also wheels. Like sometimes there's a nail in a tire. And if that goes around, it'll come around again at the same speed. Once your tire is going at the same speed, you're not slowing up or speeding down. That would also be sinusoidal function, right? You're going to go from max to min, right? That nail going around. So we need 5 coordinates before we do regression. So some people get 3 and they put it in and then their regression doesn't match. And they're like, I don't get it. Because you didn't have 5. You need that 5 coordinates. Okay? So 5, 5, 5, 5, 5. So when the test comes and you give me 3 and you're mad at me, at 3:46, I repeated 5 at least 5 times before I said 5. 5. 5, 5, 5. You could have 10. We need a minimum 5. Okay, good talk. So we're going to draw this out. So it's 1 meter off the ground. Here's my ground. Here's my little stand. Here's my Ferris wheel. It's not going to be the most accurate thing. It actually kind of looks like a balloon at this point. That's a tear. Pardonnez-moi? Oh, thank you. Look at me. Oh, I'm so smart when I make my notes. It's drawn for us. Yay. So, Ferris wheel down here. Let's put a center in it. Oh, gosh. Just going to make it bigger, and then maybe it's centered. Okay. Center on our Ferris wheel, yes? Every Ferris wheel, we're going to, or wheel, or circle, or whatever, we're going to split it into 4 pieces. So let's cut this up into 4 pieces. And each of these 4 pieces is going to have a coordinate. That's what we need to know. So I'm going to get a coordinate down here with an x and a y, and then here with an x and a y. And my Ferris wheel is going to go this direction. If they draw one, you have to go in the direction they do. So watch for the arrow, okay? I went this way, you guys can go that way, it doesn't really matter. And then this has a coordinate, like this will be a coordinate here, this will be a coordinate here. If we stopped it here, there'd be a coordinate. And then when we get back down to the bottom, we're going to get another coordinate. How many coordinates is that? 5. How many do we need at minimum? 5. Brilliant. Okay. So let's discuss. Time is always what variable? X. And the height is always y. So let's talk about height first. What was the maximum this Ferris wheel went to? 16. So I'm going to go to the y, and I'm going to go 16 meters. Yeah? Okay. The bottom, the minimum is 1. So it's going to be 1 here and 1 here. The center of this, where this middle cut is the center of the function. It would be technically the line that cuts the graph in half, correct? What is that a fancy way of saying? Midline. So I'm going to put this up here to help myself out. So center of circle is the midline. It's a fancy way of giving you the midline. 1 revolution is a fancy way of giving you what? The period. And the radius, guys, is from center up, center down. What's that the same as? No. In an equation, in a graph, center, same distance down, same distance up. Amplitude, the radius. The radius is the same as the amplitude of a function, because it's half the vertical distance, correct? Between the min and the max. So radius is a fancy way of them giving you the amplitude. They didn't give us the radius here. So in order to sketch our circle, we need the midline. How can we get a midline given that? Radius can help us get the midline because it would be 1 plus the radius or 16 minus the radius. But how do you get midline when you know a max and a min? Minusing them is amplitude. Add them. Because we want the average of the two of them. When we want the average of 2 values, what do we do with them? Add them up, divide by 2. So to get the midline, it's y equals max plus min divided by 2, which is 8.5, right? 17 divided by 2. So the midline of this circle, it's 8.5. So I'm going to go here and go 8.5. And then here I'm going to go 8.5. So that's the height. The x values are the time, correct? Remember, open book means you can use your book open, but your book open is only good if it has things on it. It's a crazy thing. So you should just fill in your notes. All right. So how do I get the x values? X is what in this case? Time. It takes us how long to do 1 revolution? 18 seconds. How many pieces did I cut this into? I can cut it into 5. I got 5 coordinates. How many pieces did I cut it into? 4. I get that 5th coordinate because we come around again, right? So I know, let's think about this. I know at 0 seconds I'm getting onto this Ferris wheel, right? Do they have to get on the bottom? They could get on somewhere else if there was like a platform or something. I really hope they don't do that to us. 0 seconds. And then when do we get to the bottom again? 18 seconds. So this is going to be 9 seconds. What's the fastest way to figure out how much each of the pieces would be? Divide by 4. Exactly. So we take the period 18 and you divide it by however many pieces, right? So it's going to be 4.5 seconds. So at 0 seconds, I'm here. 4.5 seconds, I'm here. If you go the other direction, it would be the other one. Then 9, and 9. Pardon? 13. Oh, yeah. 13.5. I thought you were saying something else. 13.5 seconds, and then 18. Yes? So we're going to sketch this. Do you see how I drew it the exact same height as the base here and through here? So this would be, it's it right in line with it. This is 0 meters. Draw this over. This would be 8.5 meters. Then draw this over. This would be what? 16 meters. And then my values down here are going to be 0 seconds, then what? This one says construct a graph showing at least one pulse, so we can do just one pulse. 4.5 seconds, then 9 seconds, then 13.5 seconds, then and then we also need a height of 1 meter, right? That's technically where we're actually starting. Then we can plot those coordinates. So we have 0 seconds, 1 meter. 4.5 seconds, 8.5 meters. 9 seconds, 16 meters. 13.5, 3.5. So if I take this circle and rotate it with respect to time, which is what an actual graph does, it lays that circle out with respect to time, and it takes it and unfolds it almost, right, and lays it out. You get a sinusoidal function. It's going to curve. You're not getting a point. Sinusoidals curve at the top. Then they curve at the bottom. Remember that? Yeah? Hey. We're going to go back up to A once you're done drawing that. Back up to A. A says, what is the period of this Ferris wheel? What was the period? Period was 18, yeah. What is the amplitude? 7.5. 8.5 is the what? The midline. Amplitude's the radius. How far is it from 1 to 8.5? 7.5, right? And then how far is it from 8.5 to 16? 7.5. So remember, radius, amplitude are the same, right? Midline and center of the circle are the same. So my amplitude is 7.5 meters. How high is the axle above the ground, the center of the Ferris wheel? 8.5 meters. They're asking you for the center, right? Now I need an equation. So what I can do is I can go time, height. I have 0 and 1. I have 4.5 and 8.5. I have 9 and 16. I have 13.5 and 8.5. And then I have 18 and 1. This one, list 2. Sinusoidal regression, right? Go. We do it to the nearest hundredth, or necessary. We get y equals 7.5. Then it says sine. Then it says whatever that b is, so 0.35. Then it says x. Then it says plus b, so minus 1.57. Then it says bracket. Then it says plus b. So it'll always tell us the order of the function. You just plug the values in, correct? Can I use a rounded function to answer any questions? Are we allowed to use this rounded function to answer any questions? When are we allowed to round? In the very last step. So I was allowed to round this because that's the last step of E. But if I ask you any questions after this, you need the whole function in order to answer questions because you can only round in the very last step, right? Allowed to round there because it's the very last step of this one. Okay, friends, what's this one? One for you to try. Go. So this one says, a wheel with a stone in its tire rolls along the ground. The wheel has a radius of 1.4. So this is the ground level. The wheel is on it this time, right? And it has a radius of 1.4. So this is 1.4 meters. This is 1.4 meters, right? Which is actually the amplitude. And indirectly in this question, it's actually the midline as well, because the wheel started on the ground, correct? So 0 plus the radius gets me to the midline. So if you start on the ground, your midline and your amplitude are actually the same. Ferris wheels are stopped and they'll start on the ground, so then it's different. Okay, let's start with our, so this is going to be the bottom, so it's 0 meters. It's an aggressively large wheel. And then this is 1.4 meters. And then this is 2.8 meters. Put an arrow on it because I'm going this way. Then we're back down to 1.4 meters. Then we're back down to the ground. Now, we keep reading. It says it rotates 5 times every 60 seconds. So is 60 seconds my period if it rotates 5 times? No. So the period is going to be 60 seconds divided by what? 5. So the period is actually 12 seconds. So I know I'm going to start at 0 seconds, and then at 12 seconds, that stone's going to be back to the bottom, correct? A junior high child, that's all you need to know. 6 seconds. So how do I know when this splits? I have to go 12 seconds divided by 4. So each of these splits is 3 seconds, right? So 0, 3 seconds, 6 seconds, 9 seconds, back down to 12. So this is 0, 1.4, 2.8, and then I have 3 seconds, 6 seconds. Sometimes they ask you for 2 full rotations, right? So then I would actually just squish this and go to 24 seconds. So you have to watch what it asks for, right? So here we're at 0, 0, 3, 1.4, 6, 2.8, 1.4, back down to 0, and we have lovely thing going on here. Okay, determine the equation that represents this function. So stat, edit, clear your lists, don't delete your lists. What happens if you delete your list? Cry, quit, give up? Don't keep writing the diploma? No, you reset your calculator, give your list back. And when you reset your calculator, do you have to change the mode? No. No, it's the best thing ever. It's where it needs to be. Don't touch it. Okay? So we have 0 and 0. 0 and 6 and 9 and 12. Shh. We have 0 and 1.4 and 2.8, 1.4 and stat, edit, calc, edit. Okay, so I get y equals 1.4 sine, and to 2 decimal places, 0.52 x minus 1.57 plus 1.4. Okay, go to your window and change your window to fit the data, right? So we know we're from 0 to 12, so I'm going to go 0 to 24 because I was like doubling it. And my height is 0 to 2.8, so I'm going to go 0 to 3 so that I can actually see the maximum. And then press graph. Now my graph doesn't show up. So you call me over and you're like, Mrs. Lepp, my graph doesn't show up. What do I do? On a diploma, I can't even talk to you. So that's a problem. I can't even be in the same room as you. In a test, I just look at you with sadness. And then I often go, y equals. And you push your y equals, and it's empty. So like no graph can be drawn because you don't have anything in it. So make sure that you remember to always move your equation over. And remember that when you're done these questions, to always clear out that y equals so you're not using a previous one, right, by accident. So I press graph and, oh, weird, I can see 2 full revolutions because I made it that way. Yeah? Okay, so it wants the height of the stone at 10.3 seconds. Did they give me X or Y?
X.
If it errors, it's because your window isn't big enough most of the time. So I put 10.3 and I get 0.52 meters. And then I move on because it's a written response and that's what I do. What do I do?
This is something at 0.55.
It's 0.5. But what do I need to do? Sentence. Determine the height of the stone when the wheel has rolled 10.3 seconds. The height of the stone when the wheel has rolled for 10.3 seconds is 0.52. Now I want you to grab out some paper because we're going to practice some logs and exponential functions. All right. So this one we can common base. So 4 is 2 to the 2. Do we have to do them in 2s? Can we just leave it as a 4? Yes. So if you did it in 2s, you're not wrong. Just make more work. 16 is 4 squared. And then we have to remember to distribute it into the entire bracket. So we get 4 to the x plus 3 equals 4 to the 6x minus 2. Same base. So if these bases are the same, that means the exponents are the same. So x plus 3 equals 6x minus 2. Get our x's together. Pick one and move it. Could have moved the x over that way. It doesn't matter. We get negative 5x plus 3 equals negative 2. Subtract 3. Negative 5x equals negative 5. X equals 1. Number 2, we can't make common base, but we can divide the 2 over. So we're going to divide that 2 over first. Can the 2 join the 3? No. And if we know initial and final, we've talked about this a lot. If you know the initial and final, we divide that initial over, right? So we're going to get 3 to the 2x minus 1 equals 4. Can't make common base. One exponent. What do I have to do to get that exponent to come down? Log base 10 both sides. So I'm going to get log, the base of my exponent is the base of my log, which friends doesn't stay friends, equals 2x minus 1. Add 1 to both sides. Log base 3 of 4 plus 1 equals 2x. Divide by 2, and x equals something. What does x equal? What did you guys get? 1.1? 1.13? Yes. Okay. Perfect. Number 3. If the variable is beside the log, or the variable is in the base of the log, ultimately you're going to have to convert to exponential. Yes? But you can only have 3 pieces of information to convert to exponential, and currently we have 4. So what do we have to do first? Divide the 2 over. So we get log base 6, 2x plus 1 equals 2. Then I can convert. Base of my log becomes the base of my exponent. With what's friends doesn't stay friends, so I get a 2. 2x plus 1. 36 equals 2x plus 1. Subtract 1. 35 equals 2x. Divide by 2, and x equals 17.5.
Yep.
Now, some people put this into their calculator and they're like, it errors. It won't let me see where it intersects. If your answer is 17.5 and your x max is 10, can it find it? No. So the good thing is getting your answer first. I know it's 17.5. I go to my x max and it has to be at least 17.5. And they'll find it. Right? So that's why it's so important to get that first. Okay, we're going to go to... So, probability of an event A. Everyone paying attention? Probability of event A, we write as P of A equals N of A over N of T. It's read as the probability of A. So what you do is this is the number of A's over the number of what? What do you think T represents? Rhymes with photo. Total. Remember, get a pen. Let's grab a pen. Get in the game. Okay. Total. So like, we've done this with pizza when you guys were younger, like little spinners, right? And there'd be one that was blue out of 8. So you'd go 1 out of 8. Probability of blue was 1. Total number of pieces was 8. 1 out of 8. Right? That's all this means. So here it says, determine the probability of drawing a king from a standard deck of 5 cards. That should say 52. That is a typo. Please put a 2 behind the 5. From a standard deck of 52 cards. So there are 4 different suits in cards. So there are 4 kings, right? Because there's 1 king per suit. So the way we would write that is the probability of kings is the number of kings over the number total. Well, the number of kings is 4. And the number total is 52. So then we get 4 over 52. And if it can reduce, we always do reduce. Take the 4 out of both, so I get 1 out of 13. And 1 out of 13 could be my answer. Or they could ask to the probability to the nearest hundredth, which would be 0.08. Or they could ask for the probability to the nearest whole percent. What would that be as a percent? 8%. Just take your probability times by 100 if you want percent. Okay? So you have to read it, because sometimes it asks the probability to the nearest hundredth. Let's just divide it out, give me what it is, 2 decimal places, correct? But if they ask to like the nearest percent, we have times by 100 and they give it. Okay? So let's look here. Consider an experiment of spinning an equally spaced triangular spinner. It's numbered 1, 2, 3. And tossing 2 coins with heads and tails. So guys, this is where we're getting that tree diagram. Remember how we talked about it, where I told you it was like the anti-gravity stuff more than a tree? So at the top we write spinner. And then we list our 1, 2, 3 outcomes. Yeah? If it was just a spinner, I would have 3 total outcomes. We agree? But it's not. It's also now a coin as well. So what are the options of a coin? So I could spin a 1 and then get a heads or tails. Or I could spin a 2 and get a heads or tails. Or I could spin a 3 and get a heads or tails. Right? But there's also, so now how many outcomes would there be? 1, 2, 3, 4, 5, 6. Because it'd be 3 times 2, right? Using the fundamental counting principle, which we talked about before. Okay. But it's not just one spinner and a coin. It's a spinner, a coin, right? So we have to keep going. So we could get a spinner, a coin. So 1 heads, heads, or 1 heads, tails, or 1 tails, heads, or 1 tails, tails, right? So we talked about this in perms and cons, and I told you, okay, we could just multiply these and get a fundamental counting principle. So 3 times 2 times 2, which we know is 12 outcomes. But I said to you, in probability, it's going to be important that we know what those actual outcomes look like. So that's why you do the tree diagram. All right. We have heads, tails, heads, tails, heads, tails. And then what we're going to do is actually list the outcomes here. So we could get a 1, heads and then a heads, or a 1, heads and then a tails, or a 1, tails and a heads, or a 1, tails and a tail, or a 2, heads and a heads, or a 2, heads and a tails, or a 2, tails and a heads, or a 2, tails and a tail, 3 heads and a head, 3 heads and a tail, 3 tails and a head, 3 tails and a tail. So that is the 12 outcomes that we would get if we use the fundamental counting principle, which is 3 times 2 times 2, which is 12 outcomes, right? That's what we did in the probability unit. Or, sorry, we're in the probability unit, firms and comms unit, right? This is just listing what they all look like, okay? You need to list them all. Yeah, come on, that's how I feel when I see that you wrote an arrow. He knew what you did without even looking. Okay. How many elements are in the total sample space? How many different outcomes? 12. And here it says, show how you can use the fundamental counting principle. So in the first blank, I would have spinner. And then I always put the number of outcomes above. How many outcomes in the spinner? 3. And then I would have coin. How many outcomes on the coin? 2. And then I would have coin again, which has. And then what do I do with all of these? Why do I multiply them? Because Mrs. Lepp said so is not a good enough reason. Because you use and means we multiply, and add means we, or means we add. I don't know what I'm talking about. Because and add can't go together. Too similar, right? So and, multiply, or add. So that's why we multiply. Okay. Now here it wants us to state the probability of obtaining a 3 and 2 heads. So we need the probability of a 3 and 2 heads. So we can use the and symbol, right? That we learned in set theory. You see how we're using other units in this unit? It's a legit thing. That's why probability is on last. Okay, so we want a probability of 3 and a 2 heads. So on the top, we're going to have the number of 3 and 2 heads over the number of what? Total. So we know on the bottom we have how many? 12. And the top, we go look at our outcomes that we wrote every single one instead of putting an arrow. And we count the number of ones that have a 3 and 2 heads. How many of those 12 outcomes have a 3 and 2 heads? 1. 1. Done. Guys, what is a prime number?
A number with only one multiple or whatever divisible that's not, itself or a 1.
Yeah, it has to be a number, so 2 factors. A number and 1. So it has to have 2. So is 1 a prime number? No, because a prime number has 2 different distinct factors. Does a 1 have 2 different distinct factors? No. So 1 is neither prime nor composite. Composite means more than 2, right? 3, 4, 5, whatever. Prime doesn't hit either of those, or 1 doesn't hit either of those. So 1, 2, and 3, how many of those are prime? 2 and 3 are prime. So we need the probability of a prime number and exactly 1 tail. You try it out. Give me the fraction. Did the total change?
No.
No, so that's 12. We need to find the ones with a 2 or a 3 and exactly 1 tail. So that's why outcomes listing is better. So we need a 2 and exactly 1 tail. So this one, not that one. And then a 3, this one, and this one. So how many are there? 4 out of 12, which reduces to 1 over 3. Okay? Then we're going to flip over. $33.
So I got 0.63.
Yeah. Okay. So this one here has a blue die and a red die are rolled. The outcome 3 on the blue and 4 on the red die can be represented in the order pair 3, 4. So if you don't have different colors, no big deal. But the blue has to be stated first and the red has to be stated last. So I like doing an array whenever it's a 6 by 6 dice because then I can physically see what outcomes I have, correct? Rather than trying to remember what outcomes I have. So all the blue numbers are going to come first, so I'm going to do them first. 1, 2, 3, 4, 5, 6. Once you've filled it in, I want you to answer A and B, please. How many outcomes are in the sample space? 36. That is not where I meant to write that. Okay. So determine the probability the same number appears on both dice. So we have to go probability, same number. So what goes on the top? The number of same numbers over the total. So we know it could be out of 36. How many of them are the same numbers? 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That reduces to 1 out of 6. And this one wants probability of an odd sum. So to help myself out, I'm going to put dots beside the ones that would, sum means doing what? Addition. That gets me a 2, that gets me a 3, that gets me a 4, that gets me a 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 7, 9, 6, 7, 9, 11, 7, 9, 11. So that's 1, 2, 3, 4, 5, 6. Oh, what's happening? 7, 8, 9, 3 per line, correct? 1, 2, 3, 4, 5, 6 lines. So how many? 18. So half of them, which makes sense.